In the previous class, we have designed push down automata for a few languages, and I've also assigned you a question to design a push down automata for accepting a language that would accept the strings of the form a power n b power 2n plus 1, such that the value of n should be greater than or equals to 1. Okay, so this language, as I already discussed in the previous class, it is like this, that you would be reading n number of a's, then you should read a single b, and after that you should read twice b as the number of a's, right? So it would be like read a's, then read a single b, and then again read twice b as that the number of a's, right? Or read n number of a followed by twice n number of b's, and then lastly a single b. In these two different ways you can implement this particular uh, automata. We have already seen a power n 2 power n kind of a strings in the previous class, right? And like this, we have seen it previous class, like we can design a push down automata that would accept the language a power n b power 2n in this way, right? We are also seen acceptance of a string for this particular automata, and then I asked you to design a push down automata that will accept such strings where the string have number of a's followed by twice the number of b as the number of a followed by a single b, right? It is 2n plus 1. So the language that will be accepted will be of this particular form. If there is 1a, then there should be 3b, because twice the number of a, there will be 2b plus 1, so an additional b. If there are 2a's, then twice a means there will be 4b followed by a single b, or a single b followed by 4b's, right? If there are 3a's, then there should be 2 into 3 plus 1, that is 6 plus 1, 7 b's, right? This kind of strings will be accepted by this push down automata. So let us design. So here the logic will be simple. There are two logic. First, read n number of a's, push n number of a onto the stack, then read a single b, don't do anything on the stack. Then on reading two b's, pop a single a, right? This is one logic. Another logic is, for a single a being read, push two a onto the stack. For another a, push another two b's on the stack, right? Then you will be reading a single b, don't do anything, and from second b onwards, push sorry, pop all a for a matlab one a for a one b, another a for another b, like that, right? Or otherwise you can read a push on the stack, read another a, push on the stack. When you start reading b, pop those a for all second b's, right? And then at the end, when there is a b in the input and z0 on the top of the stack, then just traverse, right? That would be the additional b, right, as in this particular case. Okay, and after that, if you get epsilon and z0 in the next state, then move to the final state, like so. We'll see that. So as a is in the input and top of the stack is z0, we will be pushing two a's on the stack. If a is in the input and a is on the top of the stack, again we will be pushing 2a on the stack, right? So these are the first. For reading all a's, a single a will push two a's, right? Then if b is there, the first b will be popped, right? So every b that would be there, we will be popping, because there are twice number of a's on the stack, right? 2n number of a's on the stack. Then for all this b will be popping a from the stack, right? So if there are, like suppose the string is like this, so for first a we will be pushing two b's, 2a on the stack. For second a we will be pushing another 2a on the stack, so there will be 4 a's on the stack, right? Then on reading b will pop 1a for 1b, right? So we'll be popping first b, in the second we'll pop another a, in the third b we'll again pop another a, in the fourth b we'll again pop another A on the from the stack, right? Now the stack would have Z0 because all the four A's that we have pushed, they're popped from the stack, right? And we have still a B to be read. So in Q1, if you get B as input and the top of the stack is Z0, this means this is the additional B which is required, this one, right? So we need to traverse this. We don't need to pop anything from the stack. So we'll just keep the stack as it is, Z0 as it is, and just traverse. So if B is the input and Z0 is on the top of the stack, we'll just traverse, right? Like this. There is some animation error, right? So we'll go over here in Q2, and then in Q2, if there will be no input left, if there is epsilon and Z0 is on the top of the stack, we'll move to the final state. Okay, then the same automata can be designed in another way that we have already seen for a power and 2 power, and we'll be just pushing one A and we'll pop one A when we read two B's, right? Like this. So the first logic will be same. If you get a push single A. Here we have pushed two A's. Here we'll be pushing single A. As we read a B, this would be first B. Now I am implementing in this particular fashion, right? So when first B is read, I will just traverse. I won't do anything. I won't pop anything. So this is the first B. So what I would do, I would keep the stack as it is. I will just traverse, right? I'll neither perform push operation nor pop, right? So A will be as it is. Then I move to a new state. Then from here, for every second B, I need to pop, right? So for all cases, so here when there is this is second B, I'll be just popping it. Then again first B, I'll traverse. Second B, I'll pop. Third B, I will traverse. Fourth B, I will pop. In this way it would go on, right? And at the end, uh, here there should be there would be uh, B on the stack, and then when I read B, I'll just traverse and then I'll pop similarly like this. Okay, so this is for A power n, B power 2n followed by a B, right? So that is B power 2n plus 1. This automata is for this kind of implementation only, right? For this kind of implementation, here you need to again add a traverse operation, right? For another state. Then design a push down automata to accept a language L equals to A power n, B power m, C power n such that n comma m is greater than equals to 1. Can someone tell me the logic that can be used to implement this particular push down automata?
So
Anyone?
firstly,
Yes.
so firstly, we will take the n inputs of A and push it into the stack,
Okay.
and then m number of B's and no
What
effect
will
on
do
the
for
stack.
B? What will do for B's?
Nothing, just take input.
Okay, we'll just traverse. Right. Okay.
And then for every input of C, we will
Yes.
pop A.
Very good. Right. Correct. So the
And
string
it,
that would be accepted over. Yes, correct. Correct. So the string that would be accepted by this is the number of A and number of C should be same, and there can be any number of B in between, right? But there should be at least one B because M and N are greater than equals to 1. So the minimum string that would be accepted is ABC because A is 1, C is 1, and there can be any number of B greater than 1. So minimum there would be one B. So ABC would be accepted. Then if there are two A's, then C should be 2. Whereas there can be any number of B's, 1B, 2B, 3B, any B, right? So there can be two A's followed by three B's followed by two C. If there are three A's, then at the end there should be three C's. In between there can be any number of B's. So the logic which is given by Shri is absolutely correct. What we'll do, we'll first read a and push it onto the stack like this. We always do, right? So for A, we'll push A on the stack. Then when we'll read B, we'll just traverse. We'll not perform any action on the stack. Neither push nor pop. We'll keep the stack as it is. Just we'll read B, read B, read B, read B, and do nothing, right? So any number of time we should be able to do. But once we start with the B, we should not be able to read another A again, right? So for that purpose, we would be changing a state over here. And when we get a first B, we'll keep the stack as it is and change the state. Now this change of the state will make sure that there won't be another A after reading a B, right? And now in this way, you can read any number of B. So the combination will always be like this: B as input and A on the top of the stack. Will not perform any action on the stack, will just traverse B, right? So A will be as it is. So you can read any number of B by this, but a minimum one B will be read, because this is changing the state, and we want that n should be greater than equals to 1 am, right? So there should be a traverse transition of a state over here after reading all the b's. When we start reading C, so now we need to match these C's with the A we have pushed on the stack, right? For that, what we'll do, whenever we'll read a C, we'll pop A from the stack, because number of C's should be equal to the number of A's, right? So what we'll do, we'll read a C when A is on the top of the stack. At that time, we'll pop, right? And we'll continue to do so until we get z0 and epsilon on the input and z0 on the top of the stack, right? So if this is the scenario, so if C is there, A on the stack, will pop A, right? At the end, you should get a configuration, that is, you have read the complete string, so epsilon will be the input, and on the top of the stack you should get z0. So if epsilon is the input and z0 is on the stack, then we'll keep z0 as it is and move to a final state. So this will accept the string of the type A power n, B power m, C power n, such that n and m are greater than equals to 1. Is it clear?
Yes, sir.
Okay, now someone else other than Shri should tell me the logic. Okay, this is the tuple format for the given automata. Okay, here we have three symbols. So the input symbol is 3, and on the stack we are using only two symbols, Z0 and A. So there are two symbols in the stack symbol, and there are four states, Q0, Q1, Q2, Qf. So we have mentioned that. Delta are the transitions given by this transition diagram. Q0 is initial state and Z0 is the top of the stack, and Qf is the final state. Okay, then someone other than Shri tell me the logic for this one. The language says L equals to A power m plus n, then B power m, C power n, such that nm are greater than equals to 1. So what can be the logic? There should be, the number of A's should be sum of number of B's plus number of C's. It is like that. So the language will be, if there are two A's, then there can be one B, one C, right? Because both should be greater than equals to 1. So in this case, minimum string will be A, B, C. If there are four A's and three B's, sorry, if there are three B's and two C's, so there should be in all five A's, right? So if five A's are there, then there can be two B's and three C, one B and four C, or vice versa. So I hope all of you have marked push A in the stack, then for every B pop A, and after every input of C, and pop A. Push A in the stack for every B pop A, and then after every input of C, then pop A. Okay. Okay, good, Pradeep. Okay, then. Very correct. The logic given by Pradeep is very correct. What we'll do, there should be in all, the number of A should be equal to the sum of number of B's and number of C's. So for every A, we'll push A on the stack, and then when we read a B, we'll pop A from the stack. After the end of B's, if we read a C, we'll again pop A from the stack. At the end, you should get epsilon in the input and Z0 on the top of the stack. If you reach this particular configuration, that means number of A's are equal to the total number of B plus C, right? And now B and C can be any number. This is independent. You can have 1B and 4C if there are 5 A's, or you can have 1C and 4 B's, right? You can have any combination, but the total number of B and C should be equal to the number of A's only, right? So the logic is very simple. For every A as the input, we'll push A on the stack. As soon as we read a B, this would be a confirmation that number of A's are over and there should be no A now. And for the B and C, will pop A's. So for the first B, we'll pop A and change the state to Q1 so that it would make sure that in the new state, it won't get any A as the input, but it can get a B or C. If again it gets a B in Q1, it would just pop it from the stack and it can get any number of B in Q1. As soon as it gets a C, it would again change the state so as to make sure that the next uh, there should be no B or A, right? So in Q2 you won't get any B or A as input, right? So when you read a C, you pop A and you can get any number of C's. One C will be there, but you can get any number of C. As soon as you get a C, you will pop A from the stack. Finally, when someone other than Pradeep and Sri tell me the logic for this particular question. See, those who are not answering, they won't get marks. And Bhavika Bobde, are you there?
Yes, sir.
Yeah.
Yes, sir.
Tell me the logic for this.
Yes, sir.
The next answer will be given by Ganesh Srirame.
Sir, in last problem there was a m plus one. Here it is b m plus one. So will we push b first?
How will you push B first?
Sir, here in last problem there was a m plus one. We were pushing a, and then when we were pushing b and c, we were popping out a.
But how can you push B? Okay, on reading what you will push B?
First we will push a.
What will read? What we
S-
will read?
Sir, we will read. We will read a. There is right now a. Then there will be number of B's. It will depend on the number of A and C.
Yes.
So it will like when we will push A and C, number of B will be pop out.
No. So when will you push B? You can use any symbol, but when will you push B? Under what condition?
Uh, Sir, when we will first push A,
Yes.
then we will push. Even then we will travels to B.
So how would you maintain the count? See, now when you want to do this, try to split this string. Now there is a power n, b power m plus n. This m plus n can be n plus m also, and this is m again, right?
Yes,
I am
yes.
saying like this. Okay, so what you can do, you can write it like this: a power n followed by b power n, which is again followed by b power m, which is again followed by c power m. Can you tell me the logic now? Bhavika,
Sir, we will push A. Then while pushing B, we will pop out A.
while reading B.
Yes.
Yes.
Then we will.
Then,
Then we will. When we will push C, then we will pop out B.
yes. Something, yes. Something like that, but you are not able to explain it properly. What we'll do? See, this is, we'll do it in this particular combination, right?
Yes.
So, so here you can get any number of symbol on the stack. So when you will read number of A's, you will push it onto the stack, right? Once the A's are over, you will start reading a B. So when you will start reading B, you need to change the state, and for reading all B's, you will pop A's, right? When all the A's are popped and still there is a B, so you'll get a configuration like in a particular state, suppose Q1, you will get a configuration such that there is B in the input but Z0 on the top of the stack, right? So in that scenario, what you would do if there is B in the input in the state Q1 and top of the stack is Z0, you will again start pushing A on the stack. You may push A or you may push another symbol, let us call it as B, right? So when you will start reading this B, the first B from this particular section, so in this case, when there would be the first B in B power M, that there won't be any A on the stack because it would be start of this B. So you will be having only Z0 on the stack, and in that particular thing, A will be the input. Sorry, B will be the input. So B and Z0 in Q1, you will push a new symbol on the stack, or you can push A itself. But here we want to match this, so you can push a B. You can use a new symbol. So when you read the first B from this MBs, you will push it on the stack. So you will push a B on the stack. When you read second B, you will again push a B on the stack. Third B, you will again push it on the stack. Then, after reading all these MBs, there would be MB on the stack, and you will start reading C. So when you read the first C, the combination will be there is a C in the input and B on the stack if you have pushed B, right? So there will be C and B in state Q1 itself, right? So when you get a C in as input in Q1, this indicates that now the B's are over and C is starting. So you need to change the state, and for this C you need to pop the B which is there on the stack. So for this C you will start popping and go to a new state, suppose Q3. In Q3 you can get any number of B's because there are m number of B's or m number of C's. So on reading all C's, you will be popping all the B's from the stack. After reading all the C's, if there is Z0 again in the state Q3 and Z0 on the top of the stack, then this indicates that number of B's are matched with number of C's, right? So you need to traverse to a final state. So then you will traverse to a final state. Is the logic clear?
Yes, sir.
So now move to the next question. Someone else tell me the logic for this. This is again simple. The previous one is bit logical, but now this is again simple. A power n, B power m, C power n plus m. So who will answer this? Don't.
Hello, sir.
Yes, Pratik.
Sir, we have to push A first,
Yes.
then push C and pop A.
What?
Push C, first push A.
In what scenario? When you read, when will you push A?
To read C.
No. See, you will start reading from this end only. Now, first you will read A only.
Yes.
See, the logic is number of A plus number of B's should be equals to number of C's. So you can push any symbol for these two things. So the number of symbols that are pushed over here should be popped over here when you read this particular thing.
Yes, sir.
Right? So the logic is simple. What you'll do when you read A, you can select any symbol to push. Right? So let us say take a single symbol, that is whenever you read anything, you will push A in this scenario, right? So if you get A as input, you will push A on the stack for all the number of A's. When you get a B as input, you will change the state and push again A only on the stack, right? So you can push A or B, anything. So for this A and B, you will both the number of A's and B, you will be just pushing A on the stack, right? So whenever you get a, you will push A. Whenever you get another A, you will push A. After A's, you will be getting B. So as soon as you get a B, you again push A on the stack. Again push A on the stack. but when you get the first B, change the state so that you won't be able to read A again, right? So once all the A and B are read, so if there are n A's and m B's, so you have pushed n plus m A's on the stack, right? So this would be equal to n plus m A's when you have finished reading all these. So these many n plus m number of A's are there on the stack, which are to be popped when you start reading C. Right. So again, when you start reading C, so this would indicate that you should not read B and A again. So you will change the state, and in that new state again you will pop all the C's if there are A on the stack. At the end, again you will get the configuration as epsilon z0. Okay. Look
Yes,
at the
sir.
previous logic and try to design. Try to design for this. Try to design for this also. This is same as that we have seen over here. The only how we have implemented this, the only difference is that now here A is equals to B and C is equals to D. In the previous case it was A equals to B and then again B equals to C. Now this B, the second B, is now changed to C only. This is the only difference. The logic would be similar to this, right? You just need to change state. Here this is A power n, B power n, and C power m, D power m. Here it was A power m, B power m, then B power n, C power n it was. So instead of B, now here there is C. Okay. This is the another logic. A followed by B followed by number of C's, which is equal to number of B, and at the end number of D's, which is equal to the number of A's. Try all this at home, and then this one we'll see in the next class.